So we're moving on to the cardiovascular system, and cardiovascular literally means the heart blood vessel system. So whether or not you want to throw blood in there, it kind of varies, at least if you look from textbook to textbook. But I just mainly think about the heart and the vessels. Thinking of the heart, we usually call the heart a pump, but really it operates as two pumps, which we'll talk about in the next section. The heart also separates the oxygen rich from the oxygen poor blood, and not all hearts, when you look across the animal kingdom, not all hearts do that. So we call our heart a closed circulatory system, and it's pretty efficient. The heart also creates blood pressure by just pumping, its very nature. It's putting pressure against the blood vessel walls, and it can secrete its own hormone to help regulate that. You'll learn more about that in physiology. Here's a short video clip looking at a heart surgery, open heart surgery, and you can read the YouTube comments. This person just said, hey doc, can you go ahead and take my phone and give me a little video clip when you got me opened up? And the doc was like, yeah, no problemo. Shockingly.
There we go. Yep. Great, thanks, John.
So, just a fun little intro, some background on the heart and the cardiovascular system. Let's kind of take a more superficial to deep approach. We'll look at where the heart is located, the things that cover the heart, and then we'll look at the anatomy of the heart wall. So, heart location is in the thoracic cavity, but more specifically in the mediastinum. Remember, this means a middle space. So there's this region in the thoracic cavity, roughly here, where you have not just the heart, but what we call the great vessels, the superior and inferior vena cava, the aorta, the trachea. Behind the trachea is the esophagus. So there's a lot of important, mostly tubes, in this middle space of your thoracic cavity called the mediastinum. And the heart, we know, is not shaped like this. It's actually maybe a little bit more like this. And as the heart sits in the chest, it's oriented obliquely. So if you take that shape and then put it at a diagonal going down like this, that's roughly how the heart sits. It's a little bit off center, right? So if the heart was right in the middle, it might be like this, but it's a little bit off to the left side of the body. It lies on its right side. It's a little bit tricky to show in an image, but if this is your heart, we're saying that it's a little bit oblique, a little bit to the left, and kind of rolled. You know, it's rolled on that axis. The heart sits on the diaphragm, and it sits inside the cardiac notch of the left lung. You can't make that out too well in this image, but here you can see for sure this left lung has this big space right here, the cardiac notch, where the heart sits. So the next thing we'll talk about is the coverings of the heart. And if you haven't seen this, or if it's been a while, in this video talking about serous membranes, the main serous membrane I discuss is the pericardium. So this will be a good review. Hey class, let's talk about Hey class, let's talk about membranes. There are 4 types in your body. The cutaneous membrane is just the skin. Mucous membranes line lots of places where your body opens up to the environment. Synovial membranes are in some of your joints, but I want to talk about serous membranes. Serous means watery, so these are watery membranes, but what do we mean by that? Well, look at this pink ball. Imagine that this is a membrane of some sort. Let's say it's the pericardial sac, the pericardium that the heart sits in. If my fist was like the heart, this delicate organ that's moving around a lot, it needs a special protective layer, maybe something very cushiony, very slippery and slidey, like a serous membrane. So if this is my heart, the pericardium is a serous membrane around the heart. And it's double layered. Do you see how you can't quite see my fist anymore? It's hidden inside the serous membrane, which has two layers. This is an outer layer, but there's also some of the pink is touching my fist, touching the heart. That's the inner layer. And these have different names in anatomy. This outer layer is the parietal layer of the serous membrane. Parietal means wall. You know these bones on your skull, on the walls of your skull? Parietal bones. Means wall. So the outer layer is the parietal layer. The inner layer touching the organ, touching the fist, is the visceral layer. And viscera are your organs. So this is a serous membrane. It has a parietal layer and a serous layer. It protects organs like the heart, the lungs, and some digestive organs that move around a lot. They need cushioning so that they're protected, but they also need to be able to have some room to kind of squeeze and smush around, to beat, to get big and small as you breathe in and out, or for your stomach, let's say, to churn up food. Inside this balloon right now is air, but in your body there's a fluid inside these serous membranes called serous fluid. This is a watery fluid. Again, it's to protect, provide extra cushioning, and just a nice friction-free environment for some of your organs to move around a lot. And those are serous membranes. Wow. Thanks, Dr. H. Great job. The other thing I want to mention before we move on from that is that that video clip was about serous membranes in general. So now that we know for sure we're talking about the heart, we're talking about the pericardium, we can replace some of that generalized terminology with specific terminology, meaning that serous membranes have a serous cavity, but we could call it the pericardial cavity to be more specific. And inside that cavity is fluid, serous fluid, but we can call it pericardial fluid to be more specific. It's still the same thing, we're just using precise terminology. Now, if we look here, we can see, this is just a basic image version of the video that we just went through. But looking at this slide, there are references to a fibrous pericardium and a serous pericardium. And in fact, the other thing we'll talk about in this section is the heart wall. And I really want to tackle those one at a time, although there ends up being some overlap in between. But I promise you it will make more sense if we think about these separate and then kind of combine all this information. So let's talk about the fibrous pericardium. This is separate than the serous pericardium. The fibrous pericardium is very thick, dense connective tissue. It's going to protect for sure, but a big role is anchoring the heart to the thoracic wall. And because it's fairly tough, it can prevent overfilling, and it's not reducing friction so much. That's the job of the serous pericardium, right? So this outer layer is mostly really strong and protective, and it can anchor the heart in place. Let's look at that on this slide here. So there's a lot going on in this section, right? I don't want to get into all of it right now. I just want to say, where's the fibrous pericardium? Right there. So it's the most superficial layer. I can see where it's anchoring the heart to the thoracic wall. That's the fibrous pericardium. Great. If we go back, the next thing we want to discuss is the serous pericardium. And we just watched the video, gave us a good recap about the serous pericardium, its structure, double-layered membrane, and its function. Primarily, we're talking about some protection, but primarily reducing friction to give it a nice friction-free environment for the heart to beat. So if we go ahead, there's the fibrous pericardium, but I want to see, here is the serous pericardium. Got a parietal layer and a visceral layer with a pericardial cavity in between. That would be full of pericardial fluid. Great. But that still leaves the heart wall. The heart wall is made of these three layers of tissue. Epicardium, meaning on top of the heart, outermost, superficial layer. The myocardium, referring to the muscular layer. cardiac muscle tissue. It's arranged in these bundles that kind of like squeeze or milk the heart. And the endocardium, the endocardium, the most inside heart wall layer. And that's just simple squamous epithelium, super thin, super slippery, lines the inside of the heart and the inside of blood vessels. So if we go back to our very complex diagram here, we want to jump ahead and find the heart wall. There's 3 layers, 1, 2, 3. We have the epicardium, the myocardium, and the endocardium. But what you may have noticed is that this number 1 looks an awful lot like the visceral layer of the serous pericardium, because it is. Just as this reads here, it says the visceral layer of the serous pericardium, and in parentheses, epicardium. It's the same thing. So, work through that a few times, think it over, come back to this diagram a few times, and see if you can name all these layers, name their functions or what type of tissue they're made out of, things like that. But the other way you might want to think about this is like this. If you were the heart surgeon in that video, at the opening video, you needed to cut through the pericardial sac to make that video where we could see the heart beating. So you would have put your scalpel down through here all the way into the pericardial cavity. Out would leak the pericardial fluid, and you would probably say, okay, I've made it through the pericardial sac. I've cut through the pericardium. Well, technically you didn't, am I right? Because this thin membrane here, that's still part of the pericardium. It's the visceral layer of the serous pericardium. So you didn't cut all the way through. But, you know, the heart has this outermost layer, also called the epicardium. You can't peel it off. The surgeon's not going to try to cut through that microscopically thin layer. Most of the time, I tend to, and I would suggest you tend to think about things like, once you get to that pericardial cavity, I start to call this usually epicardium, myocardium, and endocardium. I won't refer to this as often as the visceral layer of the serous pericardium, but it is also that. Okay, one last thing here to think about is the cardiac skeleton. This is bands of dense connective tissue running through the heart. It's not actually what you see here. These are these spiral and circular bundles of myocardium, the heart muscle. But this dense connective tissue is kind of doing something similar. It's running through the heart, and it's doing several things. It has a stabilization function. So it's kind of, here's a bit of it. You can see these rings. It's keeping these valves in place, along with some big blood vessels and some nerves. It helps distribute the force of the contraction when the hearts contract. It's kind of making sure that push is spread out evenly along the chamber. It prevents overexpansion. It also provides some elasticity to help spring the heart back down after it expands a bit. Really, though, the main thing we'll talk about, not for a while here, but much later in this exploration of the heart, we'll talk about how the cardiac skeleton creates this electrically impermeable boundary between the atria and the ventricles. And it's super important, but it's something we'll save and we'll get into a little bit more later. So those are the location of the heart, the coverings of the heart, including that very exciting exploration of the serous pericardium versus the fibrous pericardium versus the heart wall. You really want to get down and dirty on that and just work through it and figure it out. Plus a little look at the cardiac skeleton, which will become much more important later in our discussion. See you for the next one.